All right, in this video, this is going to be the TEAS live session number 5, and in this video, we're going to look at 4 different examples. This original live session over in my Facebook group, find that link in the description. This was 4 examples, highly condensed down to under 30 minutes, but originally it was nearly 50 minutes. So without further ado, let's go ahead and get started. So a couple of links. When I upload this entire file, all of these problems that we do tonight, I'll upload those into the group, and you can actually come in here, and if you're interested in, checking out my workbook or the multiple choice quiz, the free sample, or the 100 plus questions, you can just copy and paste those links and check them out, or you can find them all over at my website. Something I do like to stress every time I meet with a bunch of students, we have almost 50. That's awesome. That's great. But something I like to mention too, students are like, hey, where can I find a problem like this? Please, when you get a chance, this video right here is less than 3 minutes, and it talks about how you can quickly search for videos, my TEAS math videos over at my website. You can just type in a couple of keywords or one keyword, and boom, you can go straight to that video on that particular topic. A few more things before we get started tonight. I hear a lot of people saying after they test, they say, okay, I had some geometry, I had more equations, I had more geometry. And if you've read this statement here, I think the test is a mixed bag. Now, when I say a mixed bag, I think there's a whole bunch of questions that ATI has built or made for the math portion of the TEAS. And then when you go and take that test, especially on the computer, it randomly picks them. That's just what I think they do. That's just my personal opinion. But bear in mind, something to point out, when you do those 36 questions, they're going to grade 32 of them. And out of those 32, 23 of them come from the numbers and algebra piece, whereas 9 of them come from measurement and data. So you do not have as many questions coming from measurement. Measurement like geometry, data, the mean, median, mode, and even the graphs pop up in here, those tables, charts, and graphs. So most of your questions come from the numbers and algebra. But what I want to go ahead and do, I'm not going to give you as much time as what I normally do when I do my mini sessions with 10 students. I do have that available. You'll see an announcement in a group whenever I have another one that's going to be popping up. But basically in that, we can actually talk back and forth. And obviously we can't do that here in this live session, but I can see y'all's comments. And so let's get into it. Multiple choice. I'll give you a little bit of time to do these, but I want to make sure I can cover them with you too in the 30 minutes that we have. So here's the first question. Read over it, and I will come back probably in about 30-45 seconds and go over it with you. All right, so I do see one answer of B, and I see a couple. So 2 of them coming in. Very good. And let's talk about this, something that I want you to make sure that you don't mess up if you have something dealing with hours and minutes. Now, we do have a distance, rate, time problem, and I have several of these over on my YouTube channel, but the formula is if you take the rate or speed and you multiply it, hang on one second. If we take the speed or the rate, we multiply it by the time, this is going to be equal to the distance. And what we're trying to find here, or before we dive into it, think about this, folks. If you travel at a speed of 50 miles per hour, and let's suppose you travel at that speed for, say, 2 hours. If you go at a speed of 50 miles per hour for 2 hours, you would take 50 times 2, and your distance would be 100 miles. It's the same concept. So Sally, she's traveling at a speed of 75 miles per hour. That's going to be the rate, the speed. And it says, how far will she travel? We are trying to find, there's our question, how far will she travel? This is what we're trying to find, the distance. How far will she travel in 1 hour and 45 minutes? This is where you have to be careful. 1 hour and 45 minutes. So 1 hour and 45 minutes is not 1.45 hours. Nope, 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 and nope. 1 hour and 45 minutes is the same thing as saying 1 whole hour and 45 out of 60 minutes. 1 hour and 45 minutes, a mixed number approach, is 1 and 45 over 60. Now, if you grab your calculator and you look at that fraction part, the 45 out of 60, if we take 45 out of 60, we get 0.75. 45 minutes is 75% of an hour. 45 minutes is 0.75 hours. So since we already had this 1 whole hour, 1 hour and 45 minutes is 1.75 hours. This is what we want to plug into here and multiply. So rate, 75 miles an hour, times the time of 1.75 hours, not 1.45. And now if you multiply that, we will get a distance of, and I'm just going to type this into my calculator. I got one right here in my hand. We have 131.25 miles. So therefore, Sally, if we round to the nearest mile, closest answer to the nearest whole number is B. Now, I do see where somebody commented and said 105 minutes. Okay, very good. 105 minutes is 1 hour, 45 minutes. I'm so glad I saw that comment there, because if you divide this by 60, check out what you get. 1 hour, 45 minutes is 105 minutes. If we take 105 and divide it by 60, boom, same exact decimal. So thank you, Quadwo. Sorry if I did not pronounce that correctly, but that is an awesome approach as well. Take the total number of minutes, divide it by 60 minutes, since there are 60 minutes in an hour, and boom, you get that same decimal. So I'm going to hush up for a second, look at some comments. Let me know what y'all think about that. And by the way, we have 80, almost 90 people here. That's pretty darn sweet. Thank you all for tuning in. Speed formula, that is what we're doing here. So y'all, that's something good to point out too. This formula that we have here, let me just go ahead and talk about this for a second. If we have rate times time equals distance, let's talk about variables. So rate times time equals distance. I'm not using words anymore. This is the algebra. Now you can rewrite this same formula in various ways. For example, if I were to move this letter R over here to the right-hand side, that is the same thing as you taking the distance and dividing by the rate or dividing by the speed. That's the exact same formula, except now you have time by itself. Another thing we could do as well, if I wanted to move the letter T, time, if you move time over here, we can take rate equals distance divided by time. These three formulas are all the same. It's just that we're, rearranging the letters, so to speak. I mean, and are there other ways of doing the problem? Absolutely. I could sit here for 30 minutes and talk about various ways of doing this same or this problem. But what I would recommend y'all to check out is look into that rate times time equals distance. Go to my channel, look at the links up here, this right here, quickly searching and finding specific videos. Check out that video at the end of the session. But yes, there's so many ways you can do pretty much any math problem. All right, so let's move on to question number 2. This is an order of operations with fractions. I'm going to hush up for a second, give it a shot. And I will say this too, since, I'm only doing 4 problems, you will not see a problem where, I don't think you'll see a problem where you'll have to add, subtract, multiply, and divide fractions all in the same problem. But if you look at this, we are looking at multiplying fractions. We are looking at adding fractions, subtracting fractions, dividing fractions, and we're looking at order of operations. So I did want to kind of cover all of that. But I know this looks a little bit intimidating, but y'all, I want to cover all of those topics the best that I can in the amount of time that I have, and we can do all of that with one problem. So let's take it step by step, and I do see some answers. I got a C, and C is correct. So, order of operations. We do not want to handle this subtraction yet. We do not want to handle this addition yet. The thing that we want to do is go ahead and multiply these. So I'm not messing with the 2/3 for right now. And actually, let me slide this guy over. And again, taking it step by step. So we definitely want to multiply here before we do any addition or subtraction. So leaving the 2/3 alone, Bringing down the minus, not messing with it yet. Multiplying our fractions, the way you multiply fractions, you take top times top, bottom times bottom. You do not cross multiply. You do not need a common denominator. When you multiply fractions, top times top, 3 times 1 is 3, over bottom times bottom, 5 times 2 is 10. Now, I don't want to mess around with the addition yet either because we still have this division over here to take care of. So, with that in mind, when you do divide fractions, the thing I've always told people to do is keep, change, flip, or maybe you remember your math teacher back in the day saying multiply by the reciprocal. I'm going to keep, well, I'll tell you what, I'm just going to come over here to the side and do that. I'm going to keep the 5 over 6, change the division to multiplication, and then we're going to flip this fraction here. That's called multiplying by the reciprocal. And now we're just multiplying fractions again. Remember how to do that. Top times top, 15. And then bottom times bottom, 6 times 1, we get 6. Now, some of you may see, okay, all we have left, folks, is addition and subtraction. And when that's all you have left, you can just go from left to right. I know some of you may be thinking, oh, I thought I was supposed to add before I subtract. And that is not correct. If all you have left is addition and subtraction in a problem, you can do it from left to right. Something else I want you to notice, and it's okay if you didn't notice it, but you could actually simplify this fraction here. I'm going to act like I didn't see that because we're going to end up simplifying at another point in the problem. So we are adding and subtracting fractions in this problem, and what we have to do here is we have to find a common denominator. This is when you need to find a common denominator, when you are adding and subtracting fractions. So I'm going to look at my biggest denominator. Here's a little quick tip on finding a common denominator. My biggest denominator is 10. Now, 6 won't go into 10 nicely. 3 won't go into 10 nicely. So 10 is not the common denominator. What about 20? Well, 10 goes into 20, but 6 doesn't and 3 doesn't. So 20 is not a common denominator. What about 30? Notice I'm going 10, 20, 30. Well, 30 is that common denominator because 6 goes into 30 and 3 goes into 30. So I'm going to come down here and rewrite all 3 of these fractions with a common denominator of 30. Now, what we have to do here, folks, is we have to ask ourselves, okay, what are we changing here? We had a 3 originally. We have to multiply by something to get 30. Well, 3 times 10 gives you 30. As long as you do it to the bottom and the top, that's totally fine. That's our new fraction for 2/3. 20 over 30 is the exact same thing as 2/3. So let's move on to the next one. We had an original denominator of 10. We're trying to get to 30, so we're going to multiply by 3. 10 times 3 gives us 30. Do the same thing to the top. 3 times 3, we get 9, and I don't need to forget my minus and my plus. But y'all, check it out. 9 over 30 is the exact same thing as 3 over 10. And just something, for those of you that struggle with fractions and getting these common denominators and second guessing your work, y'all, check it out. 3 over 10. 3 over 10. If I take 3 divided by 10, I'm going to get 0.3. Well, let's see what we get when we take 9 divided by 30. We should get the exact same decimal because, as I mentioned a moment ago, these 2 fractions are the exact same thing. Now let's finish this off. So 6, we're trying to get 30. That's going to be 6 times 5. That does give us 30 down here. Totally fine as long as we do it to the top. 15 times 5, we get what? 75. And now finally, we can combine these. We can take 20 minus 9. Well, 20 minus 9, that's going to be 11. And then we take 11 plus 75. This is going to give us a numerator of 86 over 30. Now, if you're just tuning in, I see that we have hit 90 people in here. Again, you're not going to see one this crazy, one problem like this, but I want to make sure I'm covering adding fractions, subtracting fractions, multiplying fractions, dividing fractions, order of operations. We're covering so much stuff that you will see on the TEAS test here, but not one probably this crazy. Now we have to simplify this. Since both of these numbers are even, I'm going to divide by 2, and maybe that's the biggest thing we can divide by. If you take 86, cut it in half, divide it by 2, that is 43, and then 30 divided by 2 gives us 15, and that is choice C. All right, so when dividing I'm reading a comment. Jessica, she says, so when dividing a fraction, can you always just flip the second fraction and multiply it? That's exactly what you want to do. Yes, it's keep, change, flip. Keep the first fraction the same. You're going to multiply it. That's changing division to multiplication, and you're flipping that second fraction. All right, fantastic. Let's move on to question number 3, solving an equation with fractions. Go ahead and give it a shot. All right, so I have at least 2, maybe probably more videos on this topic of solving equations with fractions. So when you're handling equations with fractions, or pretty much equations in general, if you see parentheses, go ahead and get rid of them. Now, I know some of y'all who have watched my live sessions, watched my videos, attended the mini sessions. Some people in here I've actually tutored privately. I had this idea of saying, hey, yeah, we can get rid of them. We can get rid of these fractions. But before we do that, I want to get rid of my parentheses first. So actually, I'm going to take this and slide it over here. And let's get rid of our parentheses first. So I'm going to take this fraction, 5 over 6, and I'm going to multiply it by 2x. And this can kind of get some people hung up right here because they might say, well, what do I multiply by 2? Well, folks, this is really 2 over 1. Just like this 7 is 7 over 1. And we're using that same stuff we did in the last problem where we're multiplying fractions. So I'm going to take 5 times 2. That's going to give me 10. And I'm going to take 6 times 1. That gives me 6. And I'm going to bring my x down. So I'm getting rid of parentheses by using what's called the distributive property. So I'm going to do the same thing over here to get rid of the parentheses. Top times top, bottom times bottom. Same concept of multiplying fractions. So 5 times 7, let's not forget our minus. That's going to be 35. And then bottom times bottom, 6 times 1 gives us 6. So we have gotten rid of parentheses, and now I'm just going to bring down the rest of my junk. If you're taking notes, write this down. Equations with fractions. Equations with fractions. Look that up on my channel. So here comes that part that I'm talking about. How do we handle all these crazy fractions? If you have an equation with fractions, find a common denominator and multiply both sides by it. Find a common denominator. So we're looking at a 6, another 6, a 3, and a 4. Find a common denominator for the whole daggone thing. So 6, 6, 3, and 4. The first number, that's called the least common multiple or the least common denominator. The first number that 6 will multiply into, and 3, and 4 is going to be 12. That is the least common denominator. Now, had you picked 24 or 36, those would be fine, but I'm going to stick with 12 because that's the smallest one. So I'm going to multiply 12 by everything on both sides. So really, I'm going to do the distributive property yet again. But folks, watch what happens. Just hang tight. So multiplying the left-hand side by 12 and the right-hand side by 12. And again, so we're multiplying, but watch what happens. We're about to make this thing look 10 times better. If we distribute the 12, we're going to multiply the 12 by 10. And you may say, well, what about the 6? Folks, this is really just 12 over 1, multiplying fractions. So 12 times 10, that gives us 120. And then the bottom times bottom, 1 times 6, we get 6. Now you may think this is going to be crazy. Watch what happens. Let's take 12 times 35. This is where your calculator comes in handy. So 12 times 35, we get 420. Just don't forget to bring the correct sign down. And this will be over 6. This is going to be equal to, and let's keep on going. 12 times 4, that's going to be 48 over 3. And then 12 times 3, that's going to be 36. Let's not forget to bring our plus down. And that's going to be 36 over 4. What I want y'all to do is grab your calculator and take all of these crazy green fractions we have. When we actually divide these out now, we're going to get whole numbers. Take that first one, for example. 120 divided by 6, we get a nice whole number, 20x. Bring down our minus. 420 divided by 6, a nice whole number, we get 70. equals 48 divided by 3, 16x. And then finally, 36 divided by 4, we get 9. Look at how nice that looks. Now, before I move on and finish this, the majority of you probably can. You definitely want to be comfortable with finishing the problem from right here. You definitely want to know how to do that. You're going to have a question on the TEAS test, more than likely, that's going to have a variable on both sides of the equation. So what I have in this green box, if you can't solve it from here, this is something you need to practice as soon as possible. I'm going to tell you. So from here, let's get the x's on one side. I like to move my smaller x to my bigger x. I'm going to subtract this 16x because that's going to cancel out the x's on the right-hand side. 16x minus 16x is 0x. 20x minus 16x, we get 4x. Bring down our minus 70, and this is equal to 9. So now we have the x on the left-hand side. Let's get everything else away from the left-hand side. Let's move this 70. I'm going to add it because negative 70 plus 70, that gives you 0. It cancels out. So just do it to both sides. We cancel it out over here. 4x is equal to 9 plus 70 is 79. And then finally, one more step to get the x by itself. Since that 4 is getting multiplied, the opposite of multiplying is to divide both sides by 4. Because really what happens here, folks, is 4 divided by 4 gives you 1. So we have 1x, or just x, and this is equal to 79 over 4. Again, definitely right here. You're going to probably see an equation that has variables on both sides, so you definitely want to practice that. But the correct answer here is going to be B. Nick Vick, you asked, why does it look like I got rid of the 5 over 6? That's called the distributive property. So jot yourself down a note, look up the distributive property, and what you realize is if you have a number on the outside of the parentheses, you're multiplying by it. So in a way, I guess you could say, yeah, you are getting rid of it, but that is the fundamental idea of what the distributive property is. So make yourself a note of that. I would encourage you just to type that in on a Google search, the distributive property. Now, Daphne, she says, can you turn fractions into decimals? Of course you can. Sometimes, look at these fractions here. 5 over 6. If you take 5 divided by 6, I don't want to mess with that decimal. Now, the 4/3. If you take 4 divided by 3, I don't want to mess with that decimal because it keeps on going. I call them ugly decimals. They keep on going. The 3/4 is okay. 3 divided by 4, that's 0.75. That decimal is okay. But you can actually take the answers over here and you can plug them in to see which one works. But that can be real time consuming too, especially if the correct answer was D in this problem and you already tested A, B, C, and that can take time. And I think it's a lot faster to just try to practice your skill of solving equations to solve it instead of taking answers and plugging them in. But by all means, you can definitely do that as well. What if I added the 20? Okay, that will work. I do see somebody saying, what if I added the 20x instead? When this session's over with, please go to my website. There's a video. If y'all missed this, please watch that video right there. Once I upload these notes, watch that video. It will show you how to search my website for words, keywords. And the question was, what if we move the 20x over? And I do mention that in my videos. There's definitely more than one way to solve an equation. All right, so last problem, geometry, finding the area of a complex shape. Give it a shot. So the easiest part here is this part right here. This is just a rectangle. So that part right there, area of a rectangle, you do want to know this formula is length times width. And that's already given to us. My pen's jacking up on me. So length times width, we're going to take the 6 feet times the 5 feet, and we get 30 square feet. So that's the area of the rectangle. Automatically, I'm going to go ahead and knock out B and D because the rectangle by itself has an area bigger than those. Y'all see what I'm saying? Now, here's the tricky part. Half circle. We have a half circle that we want to find the area of, and another formula that you do want to know for the TEAS test is the area of a circle. Now, The area of a whole circle is going to be pi times the radius squared. And let me get my keyboard real quick. So that formula is for the area of a whole circle, a whole daggone circle. We don't have a whole circle here. Since we have a half circle, and what that's really called, folks, is a semicircle. I don't think you have to worry about that name. We need to divide the area by 2. When you take something and divide it by 2, you are cutting it in half. Now notice the directions did mention, use 3.14 for pi. So I'm going to come up here to this formula, area equals pi r squared. So pi 3.14 times the radius. Ruh-roh, what the heck's the radius? This 6 feet across the bottom is the same thing as what we have right here. That is the diameter of that semicircle. The diameter from one side of that circle to the other side of the circle, 6 feet. But we want the radius, that's going to be half. It's always half the diameter. So the distance from the center to the edge, this is called your radius, and that's going to be half of that 6. So we get 3. So we're taking pi 3.14 times the radius, which is 3, and we're squaring it. Now, you better not say 6 right there. Nope, 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 and nope. 3 squared is not 3 times 2. That is 3 times 3. And something to point out on the TEAS test, you do not have an exponent button. So what I would do here is I would just take 3.14 times the radius, which is 3, but then I'm going to multiply it by 3 again because that's what 3 squared means. Now, folks, this number here is the area of a whole circle that has a radius of 3. I mentioned since we have a semicircle, we want to take half of it. So I'm going to divide that by 2. When we do this, 14.13. So when we do this, it was 28.26, and this is square feet. But we want to do half of this because that formula here again is the formula for the area of a whole circle. So the one that we want is we want to take that 28.26, divide it by 2, and I think that was 14.13 square feet. So how do we get our final answer here? We're going to take the area of the rectangle, 30, and we're going to add on the area of that semicircle because we really have 2 shapes glued together, so to speak. So if we take 30 plus 14.13, that's why we get C for this final answer. You would have gotten A for an answer had you not divided the 28.26 by 2. And that's a mistake that some of y'all may have made. You did the area of a circle, but you forgot to cut it in half. That is it. Happy New Year again. And I hope this helps. I'll talk to y'all later. Good night.